So we are about to finish this lesson minerals today. I told you, look, showing this picture yesterday, that the cave was once full of water. Over millions of years, dissolved minerals in the water slowly formed these gypsums crystals, which are now considered to be the largest minerals in the world. We say gypsum crystals are among one of the largest. You have seen how big, like the whole room is covered with those big pieces of minerals. Those are gypsum. And then we spoke about all minerals. Yesterday, I've shown you how they do the test, how they streak out the hard material with the, hard mineral with the other mineral, and they see that which one is harder. That is the streak test. And then we have some of the classes of non-silicate materials here, what I'm going to explain you today, which are native elements, halides. Halides, when I say they are group 7, fluorine, chlorine, bromine, iodine. I told you even before, girls. When I say you all these bromine, iodine, you must remember the hospital and your nurse applying you that brown color solution of iodine or bromine. Remember that? Even grade 6, I have told you about. So halides are compounds that form when elements such as fluorine, chlorine combine with elements such as calcium. Halides are used in chemical industry and detergents. Chlorine, of course, used in swimming pools. These all group 7, they are antibacterial goods. In the periodic table, all this bromine, chlorine, all are antibacterial. They kill the bacteria. You know that chlorine is used in the swimming pools and the water we drink to kill the bacteria. Now, elements are like copper, silver, and gold because they are, and do you know that copper is used in making the electronic wire? Do you know about it? Sometimes you peel off the plastic of the wire and you see inside there are red brown color strings. Did anyone see it anytime? I'm so sorry, I'm not at school.
No.
Like example, I will show you how the copper wirings are. Wait a minute. Let me go to Google and show you the copper wirings. You will understand when you see this picture. See, when you plug this off, when when you take out the plastic of it, you find these.
Oh.
These all are copper. These all are copper, girls.
Yes, I've seen it before.
Conduct electricity. They let the electricity pass through. So maybe if you have done some of the experiments or something, you even have used these copper wires. I remember previously when I was small, we don't had mobile phones. We had the landlines, the telephones, the landline, the cordless phones. So that time the wires, if somebody tried to plug it off, I remember I used to sit with my dad and try to fix them out by making 2 to 3 wires joined to some of the screw which conduct electricity. Even now today, your AC or your air condition, or there's some wiring problem. Right now we all are so busy in the mobile phones, we don't try, or we are not interested in doing that. But I used to love this wiring and cable, and I used to love this to do such things. There are special colors which match, like red and green match, or blue and green. And then I used to check with blue, it doesn't work. With green, it doesn't work. With red, it works. So it was a part of enjoyment and entertainment also. Now, but of course, again, we need to be very careful with electricity. Never turn it on and do such things. Sulfates are minerals that contain sulfur and oxygen in the form of sulfur oxide. Sulfates are used in cosmetics, toothpaste, cement, and paints. Coming to carbonates, they're used in cement. I've shown you that, in old areas, like in old villages, you have seen that at home they don't paint it properly, and you stand next to the paint that will come and stick to your clothes, that white color. So that's nothing but it is all made of carbonate materials. Coming to oxides, aluminium oxides are used in aluminium. I told you where this is used. If anyone remember, think aluminium is made for your foil, and the main thing is for aircraft, airplane. The whole airplane is made up of aluminum and copper. Why aluminum? Because it is light. Copper because it is strong. They both mix and become an alloy. Sulfides are used to make batteries. In the cars also, the batteries of the cars and many batteries, they use sulfide inside. Now, example the chemical formulas, we have gypsum, that is CaSO4, calcium sulfate, kyanite, aluminum silicon oxide, pentaoxide. Okay, it's aluminum silicon pentaoxide. Why penta? Because 5 oxygen. Calcium sulfate. By looking at this, how can you tell? You will say that these are silicates and these are non-silicate. These are non-silicate because it doesn't contain silicon. This is silicate because it contains Si, that is silicon. Si, girls, is silicon. Okay. Coming here. Who is gonna say me what is the difference between a physical property and chemical property? What is the major difference between physical property and chemical property? Like example, I gave you something in your hand. I gave you salt and I tell you, tell me the physical property of it. What will you describe salt as? It is what? Salt. Solid, liquid or gas? Nobody knows that salt, is it a solid, liquid or gas?
Salt. Salt.
It's a solid. Good. And how about its color? It is white in color. It is powdered.
Yes.
So girls, try to, when I ask question, at least try to think and answer. When I say physical properties, that means its color, its taste, its state of matter. Okay. So that is the physical property. When I say chemical property, you can say salt when mixed with something gives you that. Anyways, here when you see this formula of gypsum, do you have silicon in this formula, girls? Si? You have S, that is sulfur. But do you have Si silicon? Gypsum.
Yes.
Where is silicon? Tell me, Judy. CaSO4. Do you see Si there?
As I know.
So there is no silicon in gypsum. When coming to kyanite, Al2SiO4, O5. Do you see silicon here in kyanite?
Yes.
Yes. So this is called non-silicate and kyanite is called silicate. Do you understand that? That's why the answer is gypsum calcium sulfate is non-silicate, whereas kyanite is silicate. Did you understand this?
Yeah.
To properties. I'd said you, when I say property, remember teacher gave me salt in my hand and asked me to say physical property. You said it is white in color. You said it is solid. So that similar way, we have properties of minerals. We see the color. For example, pure quartz is colorless, but impurities can make it pink color if you add impurity to it. Pyrite is golden, turns black or brown if you expose to air. So easily by looking at it, I will say, oh, this is metallic, this is silky, this is vitreous, this is waxy. This is, the names how we use. This is earthy. This is resinous. This is pearly, submetallic, waxy. All these by looking at it, I can name those. Yesterday, I've shown you in the video how they take a streak and how they make it. Remember?
Oh, yes, they scratch and it becomes a mark.
Yes, it's found by rubbing the mineral against white tile called a streak plate. The mark left is the streak. A mineral streak is not always the same as the color of the mineral. See, imagine this is black in color, but when you streak it out, it gives you red in color. So that's why the streak is not affected by air or water. For this reason, streak is more reliable than the color. Now, girls, I told you that previously this was some brown in color, but later because of oxygen and oxygen, it became black. But when you do the streak, it gives you the original color. That's why you can rely, you can depend more on the streak and not on the color of the rock. And then I told you about the luster, the way it's shiny, dull, or like example, pyrite has metallic luster. It looks as if it is made of metal. A mineral with a non-metallic luster can be shiny, which is not having metallic, it's shiny. I told you lipsticks, nowadays you use shiny lipsticks and metallic lipsticks. The metallic is not shiny. When I say non-metallic, that means it is shiny. Then I have shown you the cleavage, how it splits, how often it splits. That is called as cleavage. If you break them and again it gives you a smooth surface, cleavage. You remember that? I've shown you yesterday. They put, you know, they bang it with a hammer and then again they see a very smooth surface that has a regular fracture or regular feature that's called a cleavage. Now this scale is called a Mohs scale. Girls, you don't need to remember, but at least know that talc is a very soft metal and the hardest is diamond. At least know that talc and gypsum are the softer one, and diamond is the harder one. Now girls, how, like I have two what do you call as oh my god, what happened to me? I have two minerals in my hand, okay, and I try to see which one is harder. Now I will rub against it. Now this diamond, because it is the hardest, it can give you a streak to all of them. It can scratch another diamond. If it is not, now if I scratch talc with quartz, I cannot, because talc is soft. When I scratch quartz with talc, yes, you can see the streak. It can be scratched. So the hardness, a mineral's resistance to being scratched is called the hardness. We are using the Mohs hardness scale. Okay, density, you know, it's about how heavy it is. I will show you about the Mohs hardness scale. Wait a minute. Mohs hardness scale. Please, girls, you need to see this.
Can determine the hardness or the ability of this
Can you hear
mineral
it?
to resist scratching.
So I take two minerals in my hand, I scratch it. The harder one can scratch the soft one. The diamond can scratch everything because it is the hardest.
It's the Mohs scale to the rescue. The Mohs scale of mineral hardness is based on the ability of one mineral to scratch another mineral visibly. The Mohs hardness scale was developed in a German mineralogist. Hardness is a measure of a mineral's ability to resist scratching. He selected 10 minerals of different hardness that range from a very soft mineral like talc.
See guys, this is what? Here they are giving from one, from down they are giving one. The soft one is talc and the hardest one is 10. And they are even giving you good examples here. What all examples are for fluoride, what example is for diamond and corundum. So carefully listen to it.
To a very hard mineral like diamond. Mohs hardness is a measure of the relative hardness and the resistance to scratching between minerals. When doing the test of minerals, it's necessary to determine which mineral was scratched. Let's go through the Mohs scale. As you move up the scale, hardness increases. At number 1, talc. 2 is gypsum. 3 is calcite. 4 is fluorite. 5 is apatite. 6 is feldspar. 7 quartz. 8 topaz. 9 corundum. And then the hardest is a diamond. You can also use common household items to test for hardness. For example, a fingernail has a hardness of around 2 to 2.25. A penny is between 3 and 3.5. A nail, 5 or 6. A piece of glass, 5 or 5.5. A streak plate, around 6. And a piece of quartz, around 7. Let's determine the hardness of this mineral. First, it can scratch talc, which I know is at 1, so it's greater than 1. But it can be scratched by calcite, which has a hardness of 3. So it has a hardness of 2. This fact helps me identify the mineral using a simple chart as gypsum. If you'd like to know more about the Mohs hardness scale, this playlist will help. And as always, thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and share.
Okay, girls. So did you get it? Do you understand how they scratch and they check it?
Yes. Yeah.
Comes here. A mineral has a definite chemical composition. It's a solid. It's usually inorganic. It's formed in nature. And what is the next one, girls? What else you can write? It has a crystalline structure. That is page number 152. It has a crystalline structure. Next, minerals are classified into 2 groups. Girls, tell me which one is silicate and which one is non-silicate. Zishan, which one has silicon and which do not have silicon here in this picture? Quartz, does it have silicon?
Yes.
So this is silicate. And calcite, does it have silicon? Calcite, does it have silicon? No.
No.
There's no Si in the formula. So this is non-silicate. Minerals formed by metamorphism, the cooling of magma and lava. I told you, when they are forming metamorphic rock, the most important thing is that they have to have high temperature and high pressure. So question number 22, precipitating from solutions or high pressure and high temperature. Now number 23, colors and luster. Of course, by the streak is important. Streak, and this page is very, very important, girls, to know the characteristic of minerals. Okay, girls, 1 minute. Okay, the way light bounces off minerals surface is described by the minerals. Girls, the light what comes out, what is it called as from the mineral? What is it called, girls? The light what shines from the what do you call as mineral, what is it called as? Yes, girls, what is it called as? No one will say. The shine what comes out. Nobody's listening, that means. It's called as luster. I told you, the color of mineral in powdered form is called, or it's the minerals. The color of, it's the mineral streak. The color, whatever it is formed, is the mineral streak. And each element is made up of only one kind of, what is element made of? At least, what is element made of? All the elements are made of. Before element, what did I explain you? One small circle, what is it called as? I'm not going to say this at all. Girls, what is this? Yes?
Atom.
Excellent. Who's this?
Noor.
Very good, Noor. Excellent. It's an atom. Element is made up of an atom. Then we have element. Then we have molecules and compounds. And how can I see the color of a mineral? By scratching it and seeing the color of the streak. The light that comes out, the shiny light, it is known by the luster.
Luster.
Luster, luster. I know the lessons are boring, but girls, please try to concentrate. Okay, by this we have finished the lesson, and we need to know the rock cycle. Now, this again, rock cycle is that what we have already done, weathering, erosion, and deposition. Now, everyone know when I say weathering, let me get my pen. Wait a minute. Okay. When I'm talking about weathering, what am I supposed to draw here? Zishan, you always answer me this question, so do it now. When I'm talking about weathering, what do I draw? I draw a rock.
A rock, it's the breaking.
I'm sorry, I don't know why my rock is purple in color. Let me draw the brown color. Yes.
Weathering, the breaking down.
Breaking. Yes. The breaking of rock is called. And what is erosion? After breaking, will it stay in its place? It will move.
Change. Move.
How? By
the wind and water.
by water, by wind, by ice, by glaciers. So all of this is known as erosion. And what is after moving, girls? First it broke and then it is moving. After moving, it goes down and settles somewhere. That is called as deposition.
Deposition.
Three things. First is weathering, that breaks.
Down. Rock.
Second is erosion, that it moves. And lastly, it is
Deposition is the
process in which it is laid down, it is dropped down. Okay?
okay.
Now, when I say sedimentary rock, can somebody explain me sedimentary rock? We have three rocks, girls. We have three rocks because, all right, I'll just make for three rocks, I'll make this line and explain you. You are the one who are going to say me, okay? Because we have repeatedly explained this before. First one is the igneous rock. Second is sedimentary rock. And the last one is metamorphic. Do you know the names? Igneous, sedimentary, metamorphic. Okay, now, when I say igneous, when I say usually they are in oceans, girls. Usually sedimentary rocks are found nearby oceans. And when I say metamorphic, I'll draw both. They are both the rocks, but what is it? You apply, they are both the rock, but you apply lots of heat and pressure. Now, you have inside, seagulls, you have inside magma. You have so much of magma. What happened? You have so much of magma here inside. What is it? It is called as?
Magma.
When it comes out, this magma, no more magma.
Cools down.
Lava.
Lava and it cools down.
Yes, it comes out. It comes out. It comes out and it
Igneous
first,
rock.
and after it cools, it becomes hard to form igneous rock. Now, these igneous rocks are two types, intrusive and extrusive. When I say intrusive, that means inside, that is the magma cools and give you intrusive rock. When I say extrusive, it is the lava cools and give you extrusive rocks. This was about igneous rocks, girls. Coming to sedimentary rocks. Better sedimentary rocks, tomorrow I explain you. But did you understand? The igneous rocks, everyone?
Yes.
Yes.
So, we are going to study about okay, rock cycle. Most of the earth is made up of minerals. Rock is changing. Three main classes of rocks are igneous, metamorphic, and rock is regularly changing. The three main classes of rocks are igneous, metamorphic, and sedimentary. They are always changing. Now, Zishan, please, before I finish my class, please read the vocabulary terms.
Weathering, erosion, deposition, and
Igneous rocks,
igneous rock,
igneous rock,
sedimentary rock, metamorphic rock,
rock cycle,
rock cycle, uplift, subsidence,
and rift.
rift zone.
Okay. Thank you, dear. Any question you have regarding this?
No.
So again, weathering, erosion, and deposition. You are familiar with it. I'm not going to explain again. I told you today all about igneous rock. And tomorrow I'm going to explain you about sedimentary and metamorphic. Then we'll study about rock cycle. Next about tectonic plates. And we'll finish the lesson tomorrow. Inshallah, if we can finish the lesson easily by tomorrow, girls.
Okay.
Take care and have a nice day.